In this video, we will discuss basic rules of differentiation. Limits are hard, differentiation is easy. In section 2.6, we learned the limit definition of the derivative and the four-step process that allows us to find the derivative of a function. It's kind of tedious. Now we're going to start learning the shortcuts. For most functions we will encounter, there are simpler ways to find the derivatives. We start with four basic rules that allow us to start finding derivatives of simple functions. By the end of this section, we will be able to find the derivative of any polynomial easily. The derivative of a constant function is equal to 0. Let f of x equals c, where c is a constant. Then f prime of x equals 0. Pick any constant value for c, say 1. If f of x equals 1, then f prime of x is also 1. Then by the limit definition of the derivative, f prime of x equals the limit as h approaches 0 of f of x minus f of x plus h minus f of x over h, which is equal to the limit as h approaches 0 of 1 minus 1 over h, which is the limit as h approaches 0 of 0 over h, which is the limit as h approaches 0 of 0, which is equal to 0. For example, if f of x equals 28, then f prime of x equals 0. If f of x equals pi squared, then f prime of x equals 0. The power rule. If n is any real number and f of x equals x to the n, then f prime of x equals n times x to the n minus 1 power. If f of x equals x squared, then f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h, which is the limit as h approaches 0 of f of x plus h squared minus x squared over h, which is the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared over h, which is the limit as x approaches 0 of 2xh plus h squared over h, which is the limit as h approaches 0 of 2x plus h, which equals 2x. So if f of x equals x, that's x to the first power. So f prime of x to the first equals 1 times x to the 1 minus 1, which is x to the 0, which is 1. If f of x equals x to the 8th, then f prime of x to the 8th equals 8 times x to the 8 minus 1, which is 8x to the 7th power. And if f of x equals x to the 5 halves, then f prime of x to the 5 halves equals 5 halves times x to the 3 halves. Find the derivative of f of x equals the square root of x. We will rewrite the square root of x as x to the 1/2 power. Then f prime of x equals 1/2 times x to the 1/2 minus 1, which is 1/2 times x to the negative 1/2, which is 1 over 2 times the square root of x. Find the derivative of f of x equals 1 over the cube root of x. Again, rewrite 1 over the cube root of x as x to the negative 1/3 power. Then f prime of x equals negative 1/3 times x to the negative 1/3 minus 1, which is negative 1/3 times x to the negative 4/3, which is negative 1 over 3 times x to the 4/3 power. The derivative of a constant times a differentiable function is equal to the constant times the derivative of the function. Let f of x equal c times g of x, where c is any constant. Then f prime of x equals c times g prime of x. We can prove this by the limit definition. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h, which is equal to the limit as x approaches 0 of c times g of x plus h minus c times g of x over h, which is equal to the limit as h approaches 0 of c times g times x plus h minus g of x over h, which is c times the limit as h approaches 0 of g of x plus h minus g of x over h, which is c times g prime of x. So if f of x equals 5x cubed, then f prime of x equals the derivative with respect to x of 5x cubed, which is 5 times the derivative with respect to x of x cubed, which is 5 times 3x squared, or 15x squared. If f of x equals 3 over the square root of x, then f prime of x equals the derivative with respect to x of 3x to the negative 1/2, which is 3 times the derivative with respect to x of x to the negative 1/2, which is 3 times negative 1/2 x to the negative 3/2, which is negative 3 over 2x to the 3/2. The sum rule. The derivative of the sum or difference of two differentiable functions is equal to the sum or difference of their derivatives. Given differentiable functions f of x and g of x, the derivative with respect to x of f of x plus g of x is equal to the derivative with respect to x of f of x plus the derivative with respect to x of g of x, which is f prime of x plus g prime of x. By the limit definition, if s of x equals f of x plus g of x, then s prime of x equals the limit as h approaches 0 of s of x plus h minus s of x over h, which is equal to the limit as h approaches 0 of f of x plus h plus g of x plus h minus f of x plus g of x all over h, which is the limit as h approaches 0 of f of x plus h minus f of x plus g of x plus h minus g of x over h, which is equal to the limit as h approaches 0 of f of x plus h minus f of x over h, plus the limit as h approaches 0 of g of x plus h minus g of x over h, which is f prime of x plus g prime of x. Find the derivative of f of x equals 4x to the 5th plus 3x to the 4th plus 8x squared plus x plus 3. By the sum rule, the derivative of f of x is the sum of the derivatives of its terms, each of which can be found by using the other rules covered in this section. F prime of x equals 4 times 5x to the 4th plus 3 times 4x cubed plus 8 times 2x plus 1 plus 0. So that's 20x to the 4th plus 12x cubed plus 16x plus 1. Find the derivative of g of t equals t squared over 5 plus 5 over t squared. Note that g of t equals 1/5 t squared plus 5 times t to the negative 2. So g prime of t is equal to 1/5 times 2t plus 5 times negative 2t to the negative 3, which is 2/5 t minus 10t to the negative 3, which we can rewrite as 2t minus 50 over 5t cubed. Though honestly, in general, I am perfectly happy with 2/5 t minus t to the negative 3, or 2/5 t plus 10 over t cubed. Find the slope and an equation of the tangent line to the graph of f of x equals 2x plus 1 over the square root of x at the point 1, 3. F prime of x will be 2 minus 1/2 x to the negative 3/2, or 2 minus 1 over 2x to the 3/2. The slope of the tangent line when x equals 1 is f prime of 1 equals 2 minus 1 over 2 times 1 to the 3/2, which is 2 minus 1/2, which equals 3/2. The line with slope 3/2 that passes through the point 1, 3 is y equals 3/2 x plus 3/2.